So I was trying to explain that how restoring moment work. If bottom of a body is heavier, then CG will not displace, right? It remain at the bottom. As a result, you will get a restoring moment. So that's why when you traveling in a boat, you are going Dhaka to Borishal, you have a storm, and normally people try to go to the roof. But if you're staying at the bottom, then bottom of the boat or ship will be heavier. So due to the wave, if boat become inclined, then after wave gun, then it become stable condition. It will become straight. But if top become heavier, then it will be upside down. It will be capsize. It will not come back in previous position. Okay. Now neutral stable condition body. In that case, right over here, in that case, what will happen? Due to the wave, a board remain inclined little bit. It will not come down, come back to the previous position. It will remain in the inclined position because there is no restoring moment. But if a body has higher weight at the top, then what will happen? CG will be top of the buoyancy center. That means your buoyancy force working from the bottom of the body, upward direction, say right over here, is working FB. And weight of the body working downward through this point, it is W. Now, storm came in. And due to the storm, this CG and FB will move. They are remaining same direction. This is upward force working buoyant force, and right over here it inclined to in this direction. Due to the wave, it rotated a little bit clockwise, and W working along this direction. Now, what did you see? Your FB working upward and W becoming downward. Right over here working downward, both same direction, but they are working along the same line of action. But right now, line of action is not the same. So these two will create some, this is equal, right? Equal force working opposite direction, and their action is not going through the same point. That means they will create some moment. So that moment, you see this one working downward, this in upward. So this will try to move more, rotate more. So due to the wave, the body is inclined little bit, then due to the restoring moment, not restoring moment, destabilized moment, it will go back to, that means it will incline more. There is no possibility the boat will become straight, okay? And we can explain it more later on, that how a boat is sink and how we can minimize. That means how we can design a boat with more stable condition. Okay, so it's a neutrally stable condition. It's saying an immersed body neutrally buoyant body, buoyant mean floating, is neutrally stable if center of gravity and center of buoyancy are coincident. Body may not return to its original stable condition after small angular displacement or no restoring moment exists. He's saying in this case, if body is getting inclined a little bit, body remains the same condition, but it will come back to previous condition. That is saying that a small angular displacement or angular rotation due to the wave or other reason. Okay. Then unstable condition. It's saying this one. It's saying immersed neutrally buoyant body, buoyant mean floating body, is unstable if center of gravity is directly above the center of buoyancy. A small angular displacement causes further increase in rotation. Angular displacement rotation by overturning moment. That is moment is called overturning moment. This one is called restoring moment, and this one is called overturning or unstable moment, because it will try to make more rotation. That's why it is called overturning moment. Now, right over here, there is some parameter or some definition. By fixing that certain parameter, you can make a boat more stable, and you can avoid the overturning moment. So it's saying the measure of stability for floating body is the metacentric height. What is the metacentric height? It says GM. If you look in the middle figure, this height GM is called the metacentric height. This M and this GM. Right over here, this GM, distance GM is called metacentric height. Now we need to know. That means this distance, by measuring this distance, either it is negative or positive value, you can figure out that whether my boat is have a restoring moment or it will float with overturning moment. Okay. So what is the GM? Which is the distance between the center of gravity G and the meta center M. Now, what is the meta center? The intersection point of the line of action of the buoyant force through the body before and after rotation. So this is stable condition before rotation. Okay. And now this one is also stable, but due to the rotation, you see the buoyant force is moved toward the right, is inclined toward the right. That means he is displacing more fluid on the right side, right? This portion getting upward, moving upward. This portion moving downward. That means this portion will remain more in the water, not this. Still there will be some water, but volume will be less due to the incline. So that's why center of buoyancy is moved toward the right. So it's coming over. The longitudinal axis of the boat right over here, it remains the same. And this buoyant force line of action, you draw a line, it intersect with the central axis at point M. This M is called metacentric height. And this distance between the metacenter and center of gravity is called metacentric height. So right in this case, you see that G working along the direction, weight of the body, and buoyant force working upward, like through this point, and weight working this point. So you'll get some moment to become stabilized again. That moment is called restoring moment. But right over here is unstable body. So you see, due to the wave, it become inclined a little bit. So, but B working right over here. Okay. What is the difference over here? You see buoyant force working right side of the center of gravity. Now buoyant force is working through left side of the center of the gravity. So your CG working through this point and buoyant force working through this point. So this case, you are getting a moment that is working clockwise. That means it will try to, it will not help, it will try to sink the body. So that is called overturning moment. And this one, this is working downward, this is moving upward. So overturning moment will be anti-clockwise and try to stabilize the body. Right here is saying a floating body is stable if M, that means metacenter is above the CG, thus GM is positive. For it will be unstable if M remain below the point G. In that case, GM is negative. In later case, that means this one case, weight and buoyant force acting on the tilted body generate a overturning moment instead of restoring moment, causing body to capsize. The length of the metacentric height, GM, G is a measure of stability. So it's a the larger the GM, the body will be more stable. You, you need to keep the GM as much as possible bigger. So if GM is negative, then it will not help. You will have more overturning moment. If GM is positive, then you have restoring moment. Now, what is the application of this one? Anyone? Anyone? Storm your brain. What is the application? Okay. You traveling Dhaka to Borishal, right? You have storm, even the people in the board or in the on board or in the ship or launch, they will say, okay, could you go to the bottom? But I will not be agree, right? Because we are human being, we try to save our life. But is the huge ship, say loading in Singapore or in Beijing, and it will go to the Europe, okay? Those big ship has a huge number of container, and weight is also too much, right? And the humongous size, that means bigger size ship. How they loading? They have a spec of all the container. They use some sensor measurement equipment. They use the size of the container, volume of the container, and also weight of the container. Then they know that where is the CG of the empty boat. Okay, yeah, with all the equipment. Then they use a special software, and they got a higher salary. They distribute all the container by a software to make sure that this metacentric height, they try to keep as much as possible bigger, okay, to get the restoring moment. That is the application. They put a container, then run the software. Let's see what is the condition of the ship of the restoring moment to keep the CG in certain level. Similarly, in the aircraft industry, say they have capacity 300 passengers. Now they got only 60 passengers. How they will distribute in the allocation of seat? They'll not keep all of them at the front or at the back side. Even you have say 10 people in the business class or first class, and 60 of them in the economy class, or it's called third class, but they will distribute informally to make sure that there will be that much effect of location of CG of the airplane. Okay, how the airplane work. If you look at the front section of the aircraft, say looking at the front, this is your aircraft wing in the both side. Right? I'm sorry, this will be like that. Okay, so when this fly, the pressure at the wing work upward direction. Okay, so resultant force should work along this direction. Now CG, you are keeping over here, then you are travel. You are keeping left side, then you are travel. So try to keep the CG at the same line of action of the upward force coming from the wing pressure, from the bottom of the wing. Okay, so that is the application. A ship is floating or in movement over a fluid, right? Water. Same thing, submarine running under the water. Same thing is floating body, right? How they maintain the height of the submarine? You gradually keep some water, it will get wetter and go down. You like to coming to the top surface, by the palm you take out all the water. Okay. Same thing, a airplane, a missile is traveling inside the air and inside the fluid. This is also a floating body. Okay. So any question? Any question from anyone? No? No question? Okay. Everyone is mute. I see Niloy has his mic is still on, but he might be not here. Sadi, Mr. Sadi.
Yes, sir.
So are we able to follow the class? Is okay? Any
Yes,
problem?
sir. No, sir.
No problem? Okay. Okay, good. So we can stop it here today. Our time is already over. I took 10 minutes more. Okay. So see you on next Sunday. Okay. And we'll start a new chapter. And remember, Sunday we have exam, right? At 3:30.
Yes, sir.
Okay. So careful and have a good day.